All right, class, I'm back. All right, here we go. Now I'm going to go through on this one. I'm going to go through insert B and insert C. Insert B is just supposed to be pretty easy. So here, notice all you're doing is you're looking at your premises, conclusions, and indicator words. But notice in our other workbook, we also had this stuff called suggestive indicator words. And suggestive indicator words are just nothing other than, I think I already mentioned it, just things that are suggestive, right? Like must, like ought. I mean, whenever you see those, you think, that's probably a conclusion, right? But for like premises, okay, you know things like moreover, because it's adding to the statement, or like in addition. I mean, anything that adds to things. I mean, those are like suggestive and etc. Okay, so those are just those ideas. But knowing that, this is doing actually indicator words that are in our book. Okay, so here, right? Notice that these are all kind of, I think all these are in our book too. So here, all you're doing is, right, the conclusion and premises of an argument can be often identified by virtue of an indicator word. So here, all you're trying to do is assume the following passage are the skeletons of arguments. And this is kind of what I do with you when I do something like 1 because of 2. When I do something like that, that's like a skeleton, okay? But here, instead of 1 and 2, they would want me to do, as we go here, right? They would want me to put premise, right? Well, that was kind of ridiculous. I'd actually, in this case, I would go, right, conclusion because of premise. So instead of like my thing like that, they're basically saying, well, which one of these, 1 or 2, is going to be the conclusion? And here, this would be this one, and then, of course, the premise would be this one. So that's all it's doing. And when you have consequently, the conclusion is going to be here, which means this is a premise and premise. So means conclusion, so this has to be a premise, right? Whenever you have in as much as, that's like a conclusion. So you have conclusion in as much as, right, premise and premise. You have from blank, from premise, right, we may conclude this. Here you're going to have premise in that dot, okay? So it is raining in that, we'll bring, actually in that, I forgot, let me, I haven't heard in that in a long time. It's such an awkward phrase. So if I go, it is raining in that I will bring an umbrella. No, I bring an umbrella in that it's raining. Or maybe I bring an umbrella in that. Yeah, I'm not sure. I forgot what in that is. That's really funny. So I wouldn't use this one. It just doesn't even make sense to me. My guess is though it's a premise, indicator word, but in our books may talk about it. But I've never used it. I've been teaching this class for over almost 20 years. So we're just going to do that, okay? Like number 7, okay? So here we have an and, right, which is suggestive, but you're probably going to have premise, 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 and implies that is definitely a conclusion, okay? Again, and, premise, premise, entails is also a conclusion, right? Given, okay, so you're always going to have a conclusion, given, and usually given is usually written in terms of given that. So just giving you a heads up on that. Okay? Moving over, and so on down the line, right? 4 is a premise indicator word, so you're going to have premise, premise, conclusion. Therefore is the conclusion indicator word, right? From something, it follows that. You're going to have the conclusion there. There follows from. Now notice it follows that, but you're really saying the conclusion follows from the premise. As by, this is going to be a premise, conclusion, as is always a premise indicator word, that is a premise indicator word, hence is a conclusion indicator word, thus, but notice given here is throwing in there, thus is going to apply to this one here, and the premise is going to go there. Boop. So given that P, we're going to have conclusion, and of course here we have P because since, that was ridiculous. Let's try that again. We're going to have conclusion, since P and P. So let's have that. Insert C, okay? This is really critical. In insert C, we're really differentiating between inductive and deductive arguments. That is very, very important. Now, this particular assignment is only giving you a series of them. I'm underlining them here, okay? Now, And then obviously if the argument, okay, these are basically calling them deductive types, and they're also calling inductive types, okay? This is talking about analogies, generalizations, predictions, argument based on cause and effect, and argument to a scientific law. This right here, I would never really use this one. It's kind of a weird thing. But really, what it's an argument to a scientific law. Well, here we'll just keep this here. I don't really. Let me tell you the ones I do use on the exam. Okay. One thing I don't use on the exam is I don't use this idea of an argument from a scientific law. I mean, I don't really do that, and I don't to a scientific law, because I think those are going to be understood in different ways. Your book does go through these different types of arguments, okay? Deductive arguments, okay, they're going to always be argued, okay? It's going to be claiming. Well, you know what I'm going to do? I'm going to do this for a moment. Well, I'll do this. I'll describe what deductive is and inductive in a second. But deductive arguments, notice here, so it says definitions. Your book talks about definitions. Mathematical reasoning, your book talks about math. Now, geometrical reasoning, I'm going to just lump these two together because these two, in the essence, are math, okay? And from a scientific law, what I would say from that is like, most of the time, I mean, sure, that's fine, but it's usually kind of like a definition. So, and that's what I would describe it as. But that said, what your book is going to talk about other things, okay? Like, right? You might have other ones that like a hypothetical, okay, syllogism, and these are important. Okay, that's not. I think I might have to. Let's do this for a moment. I'm saving it. I'm just going to do this for a moment. Give me a second. I'm going to just redo this. Perfect. Okay. Your book's going to talk about hypothetical syllogisms. And notice these are any arguments with if-then. Okay? It's also going to talk about categorical syllogisms, and I'm just going to put categorical. Categorical is anything with categorical. These are things like all, none, some, okay? And then you really want to look at these in your book, okay? I'm just putting them down here. You also have disjunctive syllogism, okay? That just means either or. Whenever you have any of those things, those are always going to be deductive, okay? But you're also going to have other ones, okay? I'm going to go ahead and erase these because I can't have enough room. Your book talks about other ones. Like, for example, whenever you argue something that you can put on a timeline, they're always going to be deductive. When you're talking about age, right? When you're talking about height, these are all objective measures, okay? Like maybe you're talking about location. Again, all of these things, these are going to always involve deduction, okay? Not induction. And there we go. Let me see, what else do we have? Yeah, and that's pretty much it. I think that's all we have for that one. Let me just erase those, okay? Boom. Inductive, however, okay, your book is definitely going to talk about analogies. Your book is definitely going to talk about generalizations. Your book is going to talk about predictions. Your book will effects, but it also will bring up other things, okay? It's going to talk about signs. So in other words, if I have a watch and it says the watch says it's 24 karat gold, therefore I conclude, hey, my watch is 24 karat gold, or you got a cereal box and it says, hey, it's 24 ounces of cereal, you think, oh, therefore I got 24 ounces of cereal. All those are inductive because although you want to believe them, obviously, because of it's a sign, it may in fact be wrong. You have 23 ounces instead of 24, etc. So that's just very important. I'm running out of battery. Here we go. That's funny. Okay, so but I think your book also has, let's see, so generalizations, predictions, also when we talk in analogy, signs, cause and effect. I mean, those are really the big ones. I'm trying to think. I'm going to look at your book real quick. So, and this, of course, this whole section is chapter 3. Okay, so you do want to. I'm just going to put chapter 3 for you, so you know that. Signs. Oh yeah. Anything that uses authority, right? If I argue, hey, I believe that the moon is made of green cheese because my professor says so, well, that's an authority, okay? So you want to know that that's always induction because your professor can be wrong. And gosh, let's see. That's really kind of. I mean, those are the biggies. Those are the biggies. And it's nice that they have them here. And I think our book really does go through all of those. So that's cool. So I also want you to be able to use any of those. Please took notes on that. So let's go through this insert C. Insert C is really tough, so the idea is, well, here, let's just do this really quick. I'm just going to kind of give you a little review shot on this, okay? Deduction. And I could talk about this really a lot, and then this is so much new pen. I'm so excited. Okay, deduction. Okay, this is an argument. All right, this is very important. A deductive argument is when a conclusion, okay, claims to. Notice this is a very important part. Claims to. It's not saying that it does. It's saying it's claiming to. Right? Follow. And what typically here what we mean is with necessity. Okay, this is important. We mean 100% of the time. Okay, so make sure you know that. So in other words, the reason why math would be deductive is because it's claiming that, hey, if 1 plus 1, what do we know? With certainty, it has to equal 2. So that's the kind of thing we mean by deduction. It's claiming that the conclusion, of course, is following. But of course, like math, say 1 plus 1 is 3, obviously that's a mistake. It's wrong, but it's still, right, it's still a deductive argument because it just happens to lead to a false conclusion. Induction, on the other hand, I wish I could. Okay. Oh, it does. There it goes. That was kind of fun. I wonder if I could kind of cut. No, I can't. Okay. So here, this is when a conclusion, right, claims to follow the premises, right, not with necessity, but with probability. Okay, now that's key. What do we mean by probability? Typically we mean greater than 50% of the time. That's just like, and again, that's just an objective measure. But like if I said, hey, 3 apples, out of 3 apples, the first 3 were rancid, therefore the rest of the apples are, obviously that is an inductive argument because it's trying to argue with probability. But if I said, hey, I tasted all the apples and all the apples were rancid, well, in that case, right, there's no more probability. You're actually talking about with certainty. And so it wouldn't be induction, it would be deduction. So probability is really the key. So knowing that, this is what goes on here. So here, for example, it's just asking you, is this argument deductive or is it inductive? Let's do the example here. And again, what I always like to do is I always like to number. It's just good for the brain. Right? This calculus cost 152. Oh, no, this here, what? That's going to be 3. That's going to be 4. That's going to be 5. That's going to be 6. And then we have hence 7. Okay, so here we know number 7 obviously is the conclusion. And now the question is, what kind of pattern is going on? Okay, is it deductive or inductive? Is it claiming to be 100% or probability? So Joseph received $500, right? It says Joseph's scholarship won't completely cover the cost of his textbooks. Okay, well, Joseph received $500 scholarship. Okay, and notice and then it gives you examples of each of the costs of the books. Well, this is obviously using math. So in this case, right here it is, mathematical reasoning. And because it's using math, it's a deductive argument. Okay. Now this one I don't like it just because we can talk about it. This one, but what you really have is when you look at this one here, you have hence. We may conclude that a ray of light striking a flat reflective surface will have an angle of reflection equal to its angle of incidence. And here what you really have is you have a ray of light, right, struck a flat reflective surface at an angle of this, and it had an angle of that. Ray of light struck a flat reflective set, right, struck that, okay, at a certain thing. It had an angle of that. So notice it's saying, right, reflective surface, but then it goes an angle of that. It goes through a series of those, and then therefore it's coming to this, which is saying we may conclude that a ray of light, right, of striking a flat reflective surface will have an angle in reflection equal to its angle of incidence. Now here we didn't do this, but really what you have is this is actually what? It's inductive because it's arguing to a scientific law. It's giving you a bunch of facts here, okay? It's giving you relationships, and then the conclusion, though, right? Still a correlation. It's trying to make it a law. Laws tend to be stronger, but it could be proven wrong. Maybe it turns out that the reflection is not related to the incidence of the angle of incidence. So that's why it's that. But also, I would say the reason why you don't need that is it really also meets the requirement for cause and effect, right? It's really making a claim of what's the cause, right? We'll have an angle of reflection equal to its angle of existence. Well, the cause is, right, in fact, all of these things. So that's why when you argue to a scientific law, it really oftentimes overlaps with cause and effect. But either way, on the exam, you would get this right, okay, because you would say inductive and, right, number 5, but I would have equally have accepted number 4. Now, again, I think I mentioned this. In the exam, I'm not going to ask you, for example, to tell me what type of deductive argument it is or what type of inductive. I am going to ask you, is it deductive or is it inductive? That's what I am going to ask you, okay? So that's what you want to practice. And let's see if I can just delete all of this at once. Boom. Cool. Wait, did it? Okay, good. So then let's just go through this one, right? This one here says God is impotent, hence, right, God can eliminate evil. Obviously, this is a definition, so it has to be deductive, and definitions are right here, number 1. Okay, so there we go. I'm just going to go through a bunch of these, right? And here, this one is, right, racehorses, right, your britches, whatever, had the best times. Okay, they had the best times in the morning. Therefore, right, what's it saying? You can bet your bridges that bridges will win. Okay, so now what's interesting about this one is if it has the best times in the morning, it's going to obviously, it's concluding that, right, this is actually a prediction. Okay, because it's drawing on previous events. It's not a generalization because you're not going from a sample to a whole. You're actually making a prediction, something from the past, okay, to the future. So we know it's inductive, and in this case, it would be a prediction. Let's just even do this one. I like this one. This one's kind of interesting. It's kind of fun. So if I had this one, right, I have owned several golden retrievers, and all of them, right, have been good with children. Hence, so this is my conclusion. I believe that the golden retriever pup will be good with choice for your family. Now notice what this one is a generalization. Okay, why? Because it's really saying I'm going from what I owned in my experience, and I'm generalizing it to another family. Okay, so in this case, it is a generalization. So as a generalization, it's inductive. But let's say you thought this was a prediction, just for fun. Either way, on the exam, you would get it right because you would put inductive. But on the homework here, you would get it wrong, partly because if you put prediction here, you'd be wrong, but because it is actually is a generalization. Like here, let's just jump to number 7, right? Number 1, 2, and then we have, of course, therefore 3. So what we have here is it is certain that he will have a hangover tomorrow, and you have 1 and 2. So here we know what to expect. Why do we know he has a hangover? Well, we know alcohol causes hangover, and we know the best man at the wedding drank too much alcohol at the reception. So what's interesting here is we have what? Cause and effect. Okay, so how do we know, why do we think it's certain that he will have a hangover? Well, because the best man at the wedding drank too much, and what do we know? Causes hangover. So therefore, drink too much, causes hangover, cause, effect, he'll probably have a hangover. But here, let's look at this one. This one's good too. Number 1. Okay, but number 2, okay, and then it follows that, number 3. So we know it follows that as a conclusion indicator word, so we know that's conclusion. And we know 1 and 2, okay, these are the 2 premises, okay, and or if I read it, fence is perpendicular to the road. So here's the road, here's the fence. But his driveway is not perpendicular to the road. So here's his driveway. So what do we know? It follows that his driveway and fence are not parallel. Well, be the case, and why is that? Because if I accepted that and I accepted that, it's definitely impossible for that conclusion to be false. Okay? So this would be deductive. Deductive, okay? Is parallel and is perpendicular, then therefore they cannot be parallel. And that's just by definition. Okay, so I just wanted to throw that out there. This is a very important part. You will have these on the exam, okay? This idea of inductive and deductive. So please learn those. And the last and final video will be kind of going to something like this. When you go to inductive and deductive, you have a deductive argument. We're going to go to evaluations, okay? And when you do evaluations of arguments, first understand what deduction and induction is, because deductive arguments, when we look at things, only they, in this case, can be valid or invalid. Okay? Induction, however, can be strong or weak. And that's the topic of our next video. Okay? So I hope you enjoyed that. I hope it's helpful. And on that note, I wish you well. And remember, and I wish you well. Thank you.